With that, we're going to go ahead and get started with our opening keynotes titled Realizing Efficiency and Interoperability, SOA and Semantic Technology in the Business Mission Area. It's going to be led by Mr. Dennis Wisnowski. As Chief Architect and CTO, Mr. Wisnowski is responsible for providing expert guidance and oversight in the design, development, and modification of the federated architectures supporting the department's business mission area. This role incorporates oversight of the DoD business enterprise architecture, the corporate-level systems, processes, and data standards that are common across the DoD, in addition to the business architectures of the service and defense agencies. Mr. Wisnowski is leading the transformation of the architecture-driven business systems and services department and deployment. I believe we're going to start with a video, and then Dennis will come up.
You said he was going to key it from the back. I guess that didn't work.
Semantic technology. We all know we have many information technology challenges. One of the greatest challenges is making use of the number of structured and unstructured data sources that we must access in order to make timely, informed decisions. Even though we solved the challenge of accessing the data, we still don't be able to make much sense of it. Each data source has its own schema or data description approach with little useful metadata that can tell people and machine processes just what the data means and whether it is relevant to the decision making. To keep up with the ever-changing times and yet still utilizing what we already have, we must change the way we store, access, and share data. Taking on a semantic approach to data is the path forward. Let me show you how we're doing it. To add meaning, or what is referred to as semantics, to the data, common vocabulary is created within domains of interest. Relevant data concepts in the domain are captured along with their properties and structured according to their relationships. This structure is called an ontology. The ontology is the schema that describes the vocabulary of a domain. This creates a level of useful metadata in which humans and computers can determine the relevance of actual instance data to their activities and goals. To connect ontology metadata to actual instance data, there needs to be a way to look at the data as defined by the ontology. Instance data, expressed through the ontology, represents assertions about particular data elements. You can think of this as the authoritative content, now in an understandable form, from what were just stovepipes of structured and unstructured data. Translations between the authoritative data and the ontology occur in semantic tools that allow semantic query and visualization. A great effort has been made in finding the right DoD approach to semantic technology. Two pioneering semantic business intelligence applications have been designed to show the power and benefits of the semantic approach. Through these applications, we are exploring alternative ways of finding and exposing data. This includes dynamic access of authoritative data from various sources, ad hoc semantic representations, and the creation of semantic repositories to hold semantic instance data over a period of time. One of the greatest benefits of the semantic approach is that it allows for change, reuse, and extension without modifying systems or the underlying code. Semantic technology increases the agility and responsiveness of IT solutions, meaning that data can be pulled from many places at once with much less effort, and it reduces the total cost of ownership. Semantic technology is the future of the DoD enterprise. Join us as we all move forward with this pioneering spirit of ingenuity, simplicity, and the modernization of our data management processes.
That's a home video. I think my guys and girls did pretty good. making it. You know what you did? You brought up Brian Wilczynski's. That happens all the time. We get emails from, like, Scott Bernard. I get Brian's email. Brian gets mine.
Sorry.
It's still not the right one.
It's not.
No. Are there any questions? Yesterday, Brian was asked a question, and he answered correctly about using ontology in the semantic web, which is the future, we believe, and many others do. About 17% of the data that is on the internet that you search right now goes to some authoritative data source that's been created by some ontology mapping. That's why Yahoo says they were pioneers in this effort. It's called, today, GTRA has that name. You see it? I can't see this little screen. And then when Paul Tibbets was talking, he also used the word semantic a couple of times. So this is catching on. We were among the first in the business mission area because we have the services. I had the stick in my pocket in my room, but I didn't bring it down here.
Sorry, Dennis, we'll find it.
Okay. And so we pioneered the use of SOA in terms of a strategy. And I'm going to tell you the story. This is the next step. And this story has the parts that have to do with the technology behind it that we're developing, with the reasons why we're doing it, and then a project that we started about 18 months ago. Then tomorrow, Jonathan Underley is going to actually demonstrate the project.
Sorry, Dennis, I'm going to have to go run and grab it. So sorry.
Okay? Stay away from the speaker. Can I get up and get another cup of coffee? Are there any donuts over there? Yeah, whatever you want. It is on there because we tested it yesterday, but something happened to it. Yeah, we left the stick, and the Mac is up there too, and it's on the Mac, including the adapter. We could play the video again, yes. So ontology. Ontology has to do with the meaning of things. And the word semantic that people talk about simply is the meaning of things. And in our use of the words ontology and semantic, we set the meaning of things in context. We build a common vocabulary. We used to use the word canonical, and that seemed to be difficult to sell. It means the same thing. It means common. So we build these common vocabularies, not one, common vocabularies within the business missionary, within our domain. And our domain includes many domains that have to do with business. We have 5 principally, our PSAs, principal staff assistants. Each one of these domains is about as big as any other department in the federal government. Are we ready? So when we talk about doing things in a semantic way, in a pioneering way. Our intention is that we, of course, have to be federated with the rest of the federal government. And so that's uppermost in our mind all the time. Where I am is in the Chief Management Office. The Business Transformation Agency is being dissolved, but I was never in the BTA. I've always been in the higher organization that owned the BTA, and so none of these things I'm talking about do we expect to change. In fact, all of them are legislated, beginning with NDA 2005. And that's about the time that I came here. So you look at a massive organization like the Department of Defense, and what do you do? This is an old chart we used to use when we began this whole architecture quest. So we can actually build a model like this, and we see models that look as complicated as that, try to make sense out of that. It doesn't. So there has to be a better way. So we began to search for this better way in 2006 with the Business Enterprise Architecture version 3.0. That was a more simple architecture. At that time, the DODAF, the Data Architecture Framework, allowed for 26 products. Now we have 52 views. We reduced it down to about 11, so it was much smaller. The most important of these products have to do with how the business actually has to run. And I was asked to stay. I initially came here as a contractor, and so I said, only if I can actually build something. I'm an engineer, and I wanted to build these business processes. So that's the middle column there. That's our use of service-oriented architecture. Then we had this thing called Dimers. I'll tell the Dimers story in more detail in a few moments. The Dimers was about 11 years, about $1.5 billion, and the former Secretary of Defense said all we got was an unpronounceable acronym. There was literally no base technology that came out of that program. It was going to build a giant warehouse. And so when that was canceled, and Gordon England, former DepSecDef, sent a letter to Congress saying that we were going to do something better, build another warehouse for the entire department. That didn't seem like a good idea to me. So I looked for an alternative, and that's the right-hand column. That's the use of semantic web technology. The technology stack is in the purple. It comes from the Strategic Management Plan, the SMP. The SMP tells us what should be contained in this architecture, the BEA, the Business Enterprise Architecture. Our implementation is through semantic information, as you'll see, accessing authoritative data sources. So the traditional way of building architectures is on the left. That's simply a blueprint. All the pipes and the wires and the bricks and mortar have to be aligned. That does that. The BEA up until the next version that we're building, which will be 9.0, was more traditional. We could actually converse between these core business missions, but with difficulty. You never could get to one source of the truth. The one on the right in that picture is actually how these semantic web data stores look. They're called RDF triples. Subject, predicate, object is why they're called triples. I'll show you that. This is data that will be executable, so we can execute architectures, actually run them as an end-to-end process. What happens when we take that approach, you can see on the chart, those little blue dots, these are these RDF triple stores. These are standards, W3C standards. They're not our standards, W3C standards. So if we want to ask a question, which we do, what is the average time that a service person, dwell time, spends in theater or has spent in theater? We don't have that answer at the OSD level. The Marine Corps doesn't have that answer. They have it for their people. Army doesn't have that answer. They have it for their people. But we want the total answer. And that answer changes by the moment. So we want it right now. So we create the business process model. That's that yellow bar in the middle there, end-to-end business process model that points to the authoritative data sources that whatever service owns. So we can go down, actually execute that model, go to the authoritative data source, and bring the answer back up. It'll be one number per each service person, and it'll be an average number for all the service people. So to do that kind of solution architecture, we have to consider more than one domain. We look at this picture in the upper left there. That person wants to answer a question, like the one that I just posed. We build these stores, the RDF triple stores, that's shown in the ellipses there for each domain, for each domain. And we populate these, we populate the business process model, not the data stores. Those don't persist. They exist where they need to exist. So we don't need to own this data. We don't need to change any schema of the data. We need to build a mapping ontology. That mapping ontology, using that business process model, goes down to the authoritative data source, wherever it is, and brings the answer back up. Now, what about the cloud computing? This is a cloud. This technology does not work without cloud computing, without that notion being actually physically realized. So we have to cooperate a great deal with the CIO because the infrastructure is theirs. The data is the services or the agency, the components. So this is something that we can plan, we can envision at OSD, but we certainly can't build. Now, why is this so important? I call this the aha moment when I was thinking about about why to do this and how to do this thing about getting to authoritative data sources. There's one RDF triple star there, graph 1. They're called graphs. And if you read this graph, you see why they're called RDF triples. You can answer a question such as this: what pay grade is Colonel Blatt? Now, if I want to answer another question about Colonel Blatt, the data probably isn't in that little simple data store. Here's another one. This would be his deployment history. So this says how much dwell time does Colonel Blatt have? So we can answer questions like that. Any other question, other than those two, and a couple more, would require adding data to either one of those data stores. But why? With this technology, because each of these edges has a unique identifier, a URI, we can simply answer the question. Oh, I clicked too fast. Simply answer the question like that. It's a link. It happens. Not without a lot of work, of course, but it's that work to create two data stores independently by independent people and then cause them to link because of the standards is a lot less work, a lot less time, a lot less money than adding all the data I possibly ever want to know about Colonel Blatt into one massive data store. We're surely going to get something wrong. There's an economic imperative to do this. We have 57% of DDIT costs are in infrastructure. That means the data running around the network without ever doing anything. That number is about twice the industry average. And the best industries that have an IA issue like we do are banks. Their numbers are higher. But most other industries, all other industries, are a lot lower. So what happens is that we have all these projects. Each project has its own data. And once a project gets its own data, it wants to keep its own data in its own way, in non-standard formats. So you have costs that are going up. That number actually, that was a couple years old. Now it's about 62%. So the overhead is going up. No company could afford that kind of a situation, and now neither can we. So what we do by going to the authoritative data sources is that over time they'll shrink because they won't have to add data that they don't currently have. They just need to find it in other places. So this is a new way of thinking. And I talked about standards. To get to these standards, the first thing that we need to do is to have a new way of understanding one another. And I think I talked about the beginnings of this a couple of years ago when I was at one of these conferences. We call this our primitives approach. Why primitives? Because just like electrical engineers on the left-hand side there know what a resistor is, that little symbol, and the resistor has metadata, ohms and power in watts. The other symbol is a capacitor. That capacitor has metadata, farads, microfarads, and some of them have polarity. And then below that is another important concept of a primitive, a pattern. Any double E's here? Got to be one. So that's a filter, right? You guys, two of them here. You know that's a filter. And we know what kind of filter it is. What kind of filter is it? What did you say?
Filters have DC.
Filters have DC?
You asked what kind of filter it is.
Yes.
So it's a capacitor, it's not going to pass DC.
Okay. That is a low-pass filter. The high frequencies go to the ground. And that's what that means. So we can agree. We can agree on the primitives, and we can agree on the patterns. Now, if you don't like my double E example, what about the right side? Music. The player piano down there, it's playing mathematics because music is based upon mathematics, the same way that engineering is. So we can take a musician playing in the Pittsburgh Philharmonic and put that person in Russia, and he or she can play in Moscow Philharmonic without ever speaking a word of Russian. What about architectures? Can't do that. Unless we use standards, they all look the same. Sorry, if we don't use standards, they don't all look the same. When we use standards, they all look the same. We can read them. And if we base them on these primitives, then machines can read them. And what are those primitives? Subject, predicate, object, RDF triple stores. So the models themselves are stored in these RDF triple stores, or you also hear the word OW, Web Ontology Language. So other disciplines do this. Why shouldn't we? Another example that I use of a primitive is periodic table of the elements. There are 117 elements, and they are quite unique. We put them together into patterns. So these, at the bottom, are the primitives, and then the patterns are what's on top. We can create our symbols with more richness from those primitives. This is now the way that we do this is also a DoD standard. We base the discovery of primitives on a OMG, an Object Management Group standard, BPMN version 2 Analytical Conformance class. We don't build tools to build these business process models, so we have to have industry participate and support us. And some companies, not a lot of mention their name, but some companies are actually fairly far down this line. And as they say on the infomercials, and that's not all. We have the support of our leadership. This is from a executive directive signed by Beth McGrath on April 4th, saying that all of our architectures in the business mission area are going to be based upon these RDF triple stores. Beth likes to use the word OWL, that's a nice cute word. And the way of searching these RDF triple stores is another good word called Sparkle, also a W3C standard. And there are more standards for how we can cause these data stores to interact and how we can go from an RDF triple store to using SQL to a relational database. So this went out on April 4th, and now we're creating the supporting documentation underneath it, additional guidance, as we say, so that we can have clear and unambiguous directions to the others in the business mission area who are going to be building these architectures that can be federated together. This is another big word we've had trouble with. What do we really mean by federation? You saw it in that example. We can have one of our other domains, like personnel. Joyce is over here from personnel. We've struggled, as she knows, and as Walt knows, with this word federation. What does it mean? It means being able to link the data stores. When we link the data stores, and the data stores describe the business process model, what else is linked? The business process models. And if the business process models describe the real business, what else is linked? The business. Now, of course, it takes a lot of work to do what I just said. I'm not minimizing that. But we're doing the work anyway. Why shouldn't the result of the work make sense? That's what this is all about. So these clear and unambiguous instructions also have a transition plan, because we have a huge investment that we already have. We can't throw it away. We have to use it as best we can, including where the data is relational. How old is relational data? About 50 years, yes. And the original papers were written in the late 60s. It took us a long time to get to the point where it was useful. Now, like any curve of technology, this S-curve, we're at the top where it can't get much better. We've hit that brick wall, so to speak. This technology is about 12 years old. It began with DARPA in the late 90s, 1998. So we're at that point where we're just starting to go up that curve of accelerating advancements. This is the new thing. It'll take a long time before we run out of what we can do with it. In the meantime, of course, we have to have the two fit together, and that's what we also have done. That's what these instructions say. So the primitive series is described in a very simple way, a couple little books that Brian has put as part of the DODAF, so you could go to that website and you can see how primitives are used. And you can also see how we build these vocabularies because of the way that we build architecture. So common vocabulary is just common sense. I'm going to like to tell a little story here about a long, long time ago when I found out how important common vocabulary is. I had a sailboat, a 26-foot sailboat. Now I do flying mostly instead. But so we pulled this boat up to the North Channel of the Georgian Bay. Beautiful place. Along with 9 other boats, and I'd never met any of those people. So I only had 2 concerns on that trip. One is that I had my 3 daughters, my wife with us, and the daughters were 14, 12, and 10. One other boat had a 16-year-old boy. So I was a little worried about that. The other thing was that I have my crew of girls, and we had sailed a long time, but these other boats, there's always competition. You're out there, the wind's blowing, you want to go fast. So when I would say, go to starboard and haul in the jib sheet, I'd kind of get a stare. And so I thought I should fix that. So that night, for some reason, I had Dymo tape labeler. I labeled everything. Starboard, port, bow, stern, jib, sheet, cleat, outhaul, everything. Labeled it. At the end of the day, we always rafted the boats off, tied them together. And so we did that, and these guys are walking from boat to boat. They're seeing my boat. It had just been re-gel coated, so it was a gleaming white boat with these red markers. You could hardly not see them. And so they were laughing at me, how silly this was, to have to label everything on a boat. That night, of course, after that we all separated and spent the night around boats, different places. The next morning, we always met to plan the day. We were going to go someplace. And so what happened? That night, the wives were saying to the men, hey, that's a pretty good idea. So I was loaning my, loaning my Dymo tape labeler. You know what it did also? Not only was my boat more efficient, but at night around the campfire, we could all talk to one another because we all had a common vocabulary. Why not? So how do you build a common vocabulary? We call this CARP, Capabilities, Activities, Resources, Performers, a common way of building architectures to result in a common vocabulary. So the first thing we always do, and in the DODAF terms, this is the AV2, which is the taxonomy, which again has to do with terms in context. The taxonomy is built by, at the same time, we begin to build the architecture. The first thing we always do, back in the IDEV days, it was the same way. You always built the glossary. Always start with that. The discussions have to do with the meaning of the terms, and it's the meaning of the terms in context. That is the end-to-end business process model. So we build this architecture in this common way to get to a common vocabulary and store it in a common way. These RDF triple stores. This project, the Enterprise Information Web, is the thing that Gordon England promised to Congress, only it was called an information warehouse, Enterprise Information Warehouse. Now, it took about a year, and we'll still have people use the word warehouse. It took about a year for leadership to stop using the word warehouse and begin to use the word web, because originally it was warehouse. So this is a project now that we designed about 2 years ago, and it's been going through. I'm going to show you 6 proof of deliveries, 6 pods, one every 3 months. I'm going to show you the sequence of development of these pods. So the history is we'd spent all that money, and we didn't end up with something that we could use for personnel visibility. And so we looked at alternative ways, do it the way we had tried. That didn't work out. Traditional technology, nothing, a warehouse, and focused on the semantic web. We gave this briefing, actually this slide and some other slides, to General Cartwright about 3 or 4 weeks ago on a Saturday morning for an hour and a half. And his comment was, we tried all these other ways. They didn't work out so well. This is the only way to deal with massive amounts of data that we can, in a way we can afford. So the left side of this is we don't care where the data is. The policy for getting to that data is finding out who the people are, and DMDC, Defense Manpower Data Center, manages that for us. That name was mentioned yesterday by Paul Tibbets. These domain ontologies specific to the questions we want to ask in whatever domains we want to address. And on the right side, it says we don't care how we display the data, because this uses gadgets or widgets. Our latest pod uses Google Social. Again, an open approach. The cost then of changing any part of this is de minimis, because all the standards are there, and there are thousands, there'll soon be more, of people who learned how to do these visualization tools in a standard way, and they just do it without even thinking about it, like mashups began to be popular a few years ago. So there are some dramatic benefits. Visibility, agility, access and federation I mentioned, the use of standards that we don't have to invent. The industry does that for us and with us. And the savings are that these architectures are people-readable, machine-readable, executable. Build an end-to-end business process model. It points to the authoritative data sources based upon business rules. In DODAF terms, that's the OB6A. Brings the answer back, or says, I don't know that answer. We allow that as well. And that's better than bringing an answer back that we then find out was wrong. If you don't know the answer, where do you go first? Back to the business process model. Look at the business process model, which you had done earlier by simulation anyway. Find out what you missed. Is it a business rule? Is it a process that doesn't exist? Or does the authoritative source make a mistake? All based upon the use of these standards. So our crawl, walk, run approach is to do these every 3-month pods, proof of delivery. Initially, the contractors who were doing this didn't like that idea, every 3 months. But now, it gives us a target. How they like the idea. These are small things. I'm going to walk you through the first 6 of them. The top part of this has to do with the ontology development itself, building the business process models. That goes on. And the bottom part is, what are we going to do with that combination of the business process models and the data and the business rules that we resolve at each one of those activities, each one of those decision points in the business process model. So here was the first one. This was Christmas a year ago, 2009, that we delivered this one. And this was very simple, using off-the-shelf technology, going to a relational database, doing a query with SQL, not to prove the technology so much here, but to get people working together. I'm going to show you how we build these architectures, who are in different places at different times. DMDC in California, some developers in St. Louis, some in Washington. I don't even know where the servers are. Well, I do, but I didn't care where they were, and I didn't know in the beginning. Some are in the Pentagon, some people are in Boston. They're everywhere. And they're working each on their little parts as though they're in the same place at the same time, but they're not. So the pod progression, number 2, was to build our first RDF triple store, and to explain that. Pod 3 was to store and query multiple test data in multiple triple stores. This is every 90 days. Pod 4 was to use our first mapping ontologies, our first common vocabulary across these individual data stores. Pod 5 is to use the domain ontologies with the mapping ontology, with the source ontology. And Pod 6 is the first use of this Google Social at the top there, and a different way of accessing different data stores. Live data will be real live data will be in Pod 9. So that's about 6 months from now, because Pod 7 is right around the corner, June 30th. Each one of these is designed to teach us more about the technology to bring more people into this, especially from the services. Marine Corps and Army have been the two main people working with us so far, but the other Air Force and Navy aren't far behind. Real-world example that started to get the attention of management was when we, after the earthquake in Haiti, what if we wanted to find a person anywhere in the world, sort of like the dwell time example, who had 12 months more in the service commitment, who could be deployed in 24 hours and who spoke English and Creole or English and French. We could answer that question instantly based upon knowing where the authoritative data sources in it are and knowing that the model says that it's possible. So our ontology is many domains that are reused for any one of the domains that are subject specific, like human resources or financial management. So this is a complicated picture if we looked at it just like I'm showing here, but because the work is distributed among different people based upon the ontology concept, the work can go on in parallel. How are we sure of that? We actually build a business process model of making the business process models. So this is in our primitive form, our BPMN version 2.0 from OMG, that shows how people, no matter where they are, were directed by the workflow engine to produce their part of the product. What's the product? The product is the business process model specific to the domain, pointing to the authoritative data sources. The common vocabulary stays in a data store called, you see it there, commonvocabulary.army.mil. We didn't invent that part of it. That existed. We asked if we could use it, and the Army said yes, and so that becomes where these RDF triples are. Actually, it's in an Amazon cloud, so I don't know where it is. I know that it doesn't cost very much every month. So the people who have to build this business process model actually walk through it, like I'm showing here, and they're not done until they can answer the question and until we can execute the business process model by pointing to the authoritative data source. Now, I know that there's a lot of technology talk in this. We don't do view graph engineering. Sorry. This is real engineering to solve real problems. And it isn't specific to just HR, human resources, although that's our initial foray into this technology. It'll be used for everything that we do, following the application steps that are on the right-hand side there in that column. From FM perspective, financial management, it's the same end result, but the approach is slightly different because the way that they look at their ADSs, their authoritative data sources, is different, and they have more of them, and the laws, regulations, and policies are different. But the end result, that there are business process models that point to ADSs, will be the same, and most importantly, how we link or federate these business process models and this data together will be the same. Within the BEA, Business Enterprise Architecture, there are 15 end-to-end business process models. And one of the first things that people find out is that none of them stand alone, no two of them stand alone to answer any question. It takes three. So as we build these business process models, we build them in parallel, again using the same methodology, the same ontology approach, so that we can guarantee that federation can happen. After we were into this about a year, and it was working extremely well, literally we stopped and said, okay, what have we done here? What's our pattern that we can reuse? I'd like to have an acronym for this, but we haven't figured it out. It's data model, it's model data implement. Build the model according to the standards. Model points to the authoritative data sources. Try it. And repeat the process with governance. The part of this that's the most important, almost sounds like a cliche, but it's not, is the governance. If we didn't have total support of Beth McGrath and now Dave Wintergren with her in this case, my supervisors. We didn't have their support and then the support of others, like now General Cartwright, to do this. All the technology in the world wouldn't matter. We have to have that support. So this is a repeatable process. In our case, for EIW, for HR, it's every 90 days. And it'll be the same as we go into the other business domains. So model, data, implement, repeat. Model, data, implement, repeat. In short cycles, every 90 days. DoD IT acquisition reform talks about 12 to 18 months. That's for some larger set of capabilities. We would still do that 12 to 18 months within this 90-day increment cycle. And if this logic doesn't work, I need the other video.
Check your final position. I'm going to take her down. Wait a few more minutes, Skipper. Do as I say. It looks like... Do as I say. Give him a few more minutes. I've already waited too long. Here we go. No, we don't. Now, hold yourself, you yellow.
I went out last night after the party here and sat up by the bonfire, and there were 3 couples out there, and they said, "Where do you work?" And I said, "The DoD," and they said, "I guess we're safe." Anyway, I used that little High and the Mighty. I saw that at a drive-in movie long time ago. But sometimes, people don't want to do this. One of my favorite books of all times was the Good to Great series, and he talked about the bus. If you don't like the bus you're on, get off the bus. There are some people who won't like this, and so we'll say, fine, go and do something else. This works. I need to go. Can you go back there?
There you go.
Go and do something else. That's what I mean by that video. This is a journey. It's a process. And I said we have management totally behind us, and we're confident that we can get there. For the rest of the story, there was a very simply written article in a magazine called Common Defense Quarterly. Uses some of the same slides that I've shown here. In the first quarter issue, you can go online and download that PDF. It's a very simple story about why we need to do this. When we first started down the SOA journey, we had a seminar 2 years ago. And then last year, we had 25% semantic web, 75% SOA. This year, we're having this conference in July. And people are knocking on the door on the semantic web idea. And so this will be 75% semantic web and 25% SOA. SOA, service-oriented architecture, remains the delivery mechanism for executing these end-to-end business processes, of course. And that's what SOA is. It's orchestration of services. What semantic web adds is a common way of describing those services, pointing to data stored in a common way. So with that, I thank you for your attention. I apologize for the rough start, but I have time for some questions. She just told me out there. Sir?
How are you addressing access control?
Access control. That is the most difficult part of this. And so far, we're addressing it by thinking about it. but everybody else is the same. We have authorization-based access control, ABAC, and all we know about it is ABAC. We have a project that, and this is a big advantage that DoD has. We have investment review boards, IRBs, and with NDA 2005, it said we had to have them. So when people have an idea for a project, they have to do a business process reengineering project. They do that in the same way, using primitives, and they submit it to the CMO, the DCMO, and I see it. So I saw one that was from DFAS, Defense Finance and Accounting Services, and they wanted to build their own access control system for them. And so I exercised my authority and I stopped it. And what I did was get the CIO together with the people from DFAS and our people and NII, Brian's involved in it. And we're now beginning to figure out how to do this based upon, because we have these pockets that people can do, can manage authority. That means the rightful access to data at the element level, but it's isolated. For this to work, it has to be everywhere. So there will be an ontology, my approach, there will be an ontology for authorization policies that will be global and that will map to individual domain ontologies that will then map to individual bases, post, and exchange ontologies. That's what's going to happen. We will have this problem for some small set of EIW for HR resolved in about 9 months. That's our schedule. So 3 pods from now.
I have a question back here.
Okay?
I thought about Jeopardy and IBM Watson when you were giving your Colonel Blot and your Haitian earthquake example. And I know IBM has been shopping for, looking for business applications for Watson. You know if they've approached DoD or is what you've been talking about kind of similar to that?
Yes, it's kind of similar. IBM had Watson parties. Anyone go to a Watson party? No? A couple people. I went to the one in Washington. And it was fun. It was the night of the final Jeopardy game. And someone asked the question about, are you using semantic web, are you using an ontology approach? And the answer was yes. They began by going to, it's an ontology managed by MIT. So they populated their data stores beginning with that ontology and then added many, many, many more to it. The way that they store the data, the way that they manage all their multiple parallel processors is different. It's quite specific, and it's hardwired. So they began with the ontologies they could find, but the implementation is different. And over a period of time, as hardware matures, that part of it will change. The part of beginning with ontologies will not change. Watson is a good news story for us. Yes, sir.
On the civilian side of the government, is focused on going down the road of something called the National Information Exchange Model. Could you kind of describe your view of what you're working on the DoD side with semantic web and how these will be able to play together?
I always wish no one would ask that question. If you look at the architecture of NEAM, and it's a giant big book, it is based upon semantic web technologies. It is. It reads perfectly consistently with what I'm talking about in theory. But in practice, what they've chosen to do is to agree on standard XML strings. And so the standard XML strings are there. We could map to those, to the pointer to get us to those strings. But an XML string is not an ontology, never was intended to be. Now, the representation of these RDF triples is in XML. If you look at underneath of RDF and OWL, it's XML. But you got there by building an ontology top-down. If you begin with an XML string and try to go backwards, it's very expensive and probably, in most cases, not worthwhile. So we need to figure out how to map to that kind of an approach. Again, my prediction is that when they get some experience, and I've talked to them, of course, why did you do that? Well, because we're dealing with municipalities like Bedford over here or Everett, and they don't have that level of sophistication. I personally don't believe that. I grew up here in little Washington. So for us to sit in big Washington, that's little Washington, PA, and think that those people out there can't get it is just wrong. But it's done, and so we'll have to figure out how to work with it. Yes, sir.
Yeah, hi. I know where Little Washington's at too, by the way.
Little Washington.
Yeah. So I'm from HHS, And we had a report that came out. It was a President's Council Advisors, some science and technology report that said that the healthcare data should be moving to the semantic web. And so we've been wrestling with that. But I heard two things here that maybe that report missed. One was not heard anybody talk about how you bring the business process models into a formal, rigorous engineering path to get you on the governance plane to get where you need to be. So we can take that offline and read up on that. The question I had, though, was more practical, is rather than looking at the whole healthcare industry, electronic health records flying around the web, what I'm hearing from you, though, is that this could actually be used for the administrative systems within HHS or CMS, Medicare, Medicaid services. So you're using this as your administrative systems, right?
Yes.
So what I have an issue there then is, would be how do you introduce this when you have all this legacy baggage? You can't do a big bang. So is there a way that you can progressively, stub out, the old and the new so that you can, over time build and just replace over 10 years rather than 1 year?
Yes, this will be over 10 years. This is not an instant thing. The two parts of what you said. Yesterday when Paul Tibbers talked about EHR, electronic health records, and a 2B health architecture, that began with the Lean Six Sigma project. And Lean Six Sigma uses value chain. They do value chain analysis. One of the other things that we're doing is that these value chains will now be built using the same methodology. So we have value chains using OMG, BPMN, Analytical Conformance Class 2.0. We have BPR doing the same, and we're doing this within the business mission area on a domain-by-domain basis. So all these people who were working before, each in their own way, now work in the same way. So over time, these legacy applications, legacy systems, legacy approaches get replaced from the top down by building business process models, and from the bottom up, initially by doing mapping ontologies, and then by changing the data stores. So bit by bit by bit. In healthcare, the first thing that they're looking at is pharmacy. And that makes a whole lot of sense. We're doing joint basing, for example, within the department is popular now. That means that instead of Army, Navy, Air Force, Marines all having administrative responsibility, each separately on a base, there'll be one in charge. And so things like pharmacy, being able to get medications for warriors in one way without making mistakes, that seems like a good place to start. And we'll talk offline about some other. Anybody else from this part of the country? No? That's surprising. Maybe not. I am from Washington, PA, which is about 100 miles west from here. And so this was a popular place for us to come west, and it's a popular place for people to come from the east as well, from big Washington. Any other questions? I have about 2 minutes. All on this side. Patty. Sure. When we started, the contractors had two issues. One was that we were saying, here's how you have to build these business process models. And they had to learn this new way, but this new way is based upon the standard. So it isn't the DoD way. It's the way that all the international members of OMG have figured out you should build. Now, we limited the size of these, of the number of primitives. So it's less, and we have formulas for how patterns are built with primitives. So they got over that. And then the 90 days. Oftentimes, we would write a contract in the past or the present, and the first 90 days is spent agreeing on the specifications because we're trying to look out a decade or more, and the whole technology changes 5 times in that decade. So what we've done is said, let's put together a 4-year plan, and that 4-year plan is the vision, what we're going to have at the end of 4 years. So it's not much of a plan. 2 years, it is a plan. That 2-year plan is made up then of these pods every 90 days, every 3 months, so 8 of them in 2 years. And even there, The 8th pod isn't so clearly in sight, but the next 2 are. So we focus on this rolling cycle of 90-day pods. And once they figured out that we were serious, like the first one was December 30th, 1st of 2009. And they did it on December 19th. Now, their first request was, let's make it January 30th. No one wants to work over Christmas. And our answer was no. We will do it on December 30th, no matter how you get there. So on the top, governance, and another thing that happened, VIPS, virtual input, virtual in-processing system, something acronym like that. It's for recruiting. And there again, when we wrote into the RFP that there will be a business process model based upon BPMN 2.0, there will be a graph-based. We couldn't get acquisition to put in RDF and OWL. New ones will be, but sitting on a graph-based data store. Beth McGrath got a call from every one of the contractors saying, we don't want to do that. And she said, then don't bid. This is America. You don't have to. But it was as simple as that. I mean, once you start down this path, you have to have, like the John Wayne movie, you got to be like that, or it won't work. One more question.
You talked about re-engineering or normalizing the various databases for interoperability. But couldn't you just look at these databases, legacy databases, as black boxes? I mean, for years we've used standard query language and select statements, and that seems to work pretty well. Can you explain the difference between the availability of a standard query language? Most of the vendors support that, and the delta that you're talking about, the difference between what we have in SQL and what's necessary for your type of application.
Okay, there are 2 things that you said there. One is the data store. The data store could be relational database. We don't care about that because we do a mapping ontology to the existing schema. The second thing you said is that many, many people know how to write SQL queries. That's true. There are 2 problems with that. One is that SQL as a standard has been implemented differently by every single supplier of, quote, a SQL relational data store. So we can't really count on all SQLs being the same. But we've built a thing called a Sparkleizer. And what the Sparkleizer does is take this query language called Sparkle, which is a standard, and enable you to generate SQL statements to query a relational data store. We do that. That works for the reasons you said, but it's not the best long-term answer. The best long-term answer is literally standing by the principle of this is the standard, period, and you'll obey it. Or not. And what's wrong with that? Music. This player piano out here is based upon standards. You can't change them or you get noise, not music. I'm a pilot. I fly airplanes. There's one standard language worldwide for aircraft. What is it? English. Even more important than that, there is one standard for how every chart looks. It's in English. Every symbol is the same worldwide. And that's why an autopilot can interpret those symbols and get you there safely with one accident every 13 million miles. That's what this is all about. It's not limiting flexibility, it's increasing flexibility because the stuff will work together faster, cheaper. So thank you very much. Appreciate the chance to be here. I'll be here all day.